Hello again, friends. We're taking another look at Kythe, the system for indexing programming languages. This is part of a series of looking at things that could be useful for having an AI understand your code base, particularly the larger code bases. And what Kythe does is it indexes and understands and adds cross-references to your repos. And it's especially good for scaling to larger repos. You might think of it as the sort of thing that your IDE does for small projects, or often projects that have a single programming language. Kythe is for larger projects and ones that have multiple languages in them. It was originally an internal project at Google called Grok, and they open sourced it, or they cloned it and then open sourced it. I don't really know entirely the provenance. And I don't know how healthy it is. It seems to have some recent commits. For example, a Rust extractor. And we spent some time looking at Kythe last week. We've looked at similar things, as I mentioned last week, like source graph and some compiler stuff before. But I thought this would be good to look into. And so what I wanted to do today is focus on a part that I think that we missed that was a big part of what I was looking for originally, which is the CXX directory. And I think that this is going to be where Kythe interacts with the Bazel build system. And I'll post, there's a Kythe talk, I'll post it so that people can see it from one of the authors. And in a nutshell, one of the things that they talk about from a design perspective is that since all of the indexing stuff that you need, like lexing and parsing and resolving symbols, that's basically the front end of a compiler. And so projects tend to rebuild all of that functionality, often in sort of hackish ways. And one of the ideas of Kythe is just to reuse the existing compiler infrastructure and get that stuff more or less for free. So that's the theory. And so I wanted to see some of that in action. And I don't know really where to start. Maybe we'll start in common. The documentation, at least for Google projects, tends to be pretty good. We might look at docs. The docs should all be, I think, mainly online as well. And the extractor and indexer and tools and verify. Let's just do all the things. And actually, before we do all the things, let's grab this tab that I don't think I need anymore and look up the, what's it called? Do I still have? There's a Bazel thingy here. I forget what, I'm blanking on the name, Bazel aspect. So I want to see what, if I think that we did see before I left last week that there wasn't a reference to aspects. So I wanted to see if we can find that. And that might be a good entry point as well. All right, so we do have here in this aspect at BZL, we do have something about aspects. It says extra aspects. I don't know what that means. Maybe it's not like the main scene. We have other Bazel-y things. Bazel artifact selector, aspect, artifact selector, serialization format, and so on. I don't know which of these will be the most important. How about Google Dev Tools, Kythe extractors, Java Bazel aspect? This will be some Bazel file, or basically like a version of Python. And when we call extract Java aspect on the target in the context, we're going to call this underscore extract Java, which is presumably just an idiom, meaning that this is like the internal version. Let's see if we can find it. Okay, here's underscore extract Java. If Java info not in target, so Java info is what, a string? No. It's something. Oh, they're importing something called, it's some definition, some Bazel definition, presumably like a way of modeling the Java info, what, like document, Java, no, that's different. Java doc modeling some part of the Java ecosystem. Or no. So it's a Bazel specific thing. It encapsulates information about Java and Java-like targets. Okay, so if there's no Java info, then we don't have any, in practice, Java-like targets. So we just exit out. And then we set Java compiler action none. And that's going to be overwritten as we loop over the actions in the target. And we get a Bazel mnemonic thing, which I forget entirely what it is. And we're checking if it's underscore mnemonic, in which case we, I think the mnemonic is telling us like what we're supposed to do with this stuff. And we set the Java action appropriately. Okay, so what does that mean? I don't know. This is setting some owner stuff and so on and so forth. We're getting info, compilation info, annotation processing. And I don't see anything here that really jumps out as what I'm looking for, but that's okay. And while we're, I guess, here, let's look up Bazel, the Bazel aspect documentation again. This should basically just be you're visiting different nodes, or I don't know if it's at the node level or if it's like at the function callback level in Bazel, but you are able to extract additional information. Aspects allow augmenting build dependency graphs with additional information and actions. Some typical scenarios when aspects can be useful as IDEs that integrate with Bazel can use aspects to collect information about the project. And code generation tools can leverage aspects to execute on their inputs in a target agnostic manner. I don't know what they mean entirely by target agnostic. For example, a build file. Build files can specify a hierarchy of protobuf library definitions, and language agnostic rules can use aspects to attach actions generating protobuf support code for a particular language. Okay. So I guess this is saying that like this hierarchy here is in the protobuf world, like the protobuf source files. And then from those, you're going to generate other targets that are the generated code. Here are the aspect basics. Maybe I can turn off Dark Reader here. Sorry about the bright flash of light. So consider we have some build file that has a bunch of libraries. This defines a graph. In Bazel, it's the build dependency graph. And it analyzes this dependency graph by calling an implementation function on the corresponding rule, in this case Java library, for every target in the above example. The rule implementation functions generate actions that build artifacts such as jar files and pass information such as locations and names to those artifacts to the reverse dependencies of those targets in providers. To the reverse dependencies, okay? Aspects are similar to rules in that they have an implementation function that generates actions and returns providers. However, their power comes from the way the dependency graph is built for them. An aspect has an implementation and a list of all attributes it propagates along. For example, consider an aspect A that propagates along attributes called depths. This aspect can be applied to a target X, yielding an aspect application node A of X. During its application, aspect A is applied recursively to all targets that X refers to in its depths attribute. That propagates along. So you're just telling it that it's just what it says, I guess. You have some aspect, and you tell it how you want it to interact with the graph. In this case, you want it to apply to depths, and so it's just going to apply to the depths. Thus, a single act of applying aspect A to a target X yields a shadow graph of the original dependency graph of the targets. All right. So A of W is the aspects of W. And for all of W's dependencies, we get a corresponding aspect node. And here's a simple example. So an aspect has an implementation, which is that thing, and the aspects are depths, and the required providers are CC info I don't really know how required providers work, but presumably somehow it's going to determine that it only needs to operate on things that are C++. And so if the role is a sources attribute, iterate through the files that make up the sources and print their paths. Okay. And then required providers, blah, 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 is a list of providers that allows the aspect to limit its propagation only to target, whose rules advertise its required providers. Okay. That's all useful. And so we're going to use this infrastructure to somehow query information about the files that we're looking at, and then we're going to use that to build the Kythe index. All right, now back to the Kythe source code. We're not going to look at I don't want to look too much at the Bazel code itself. I think I want to look at the C++ code. Here's docs. We'll ignore docs. So here's the indexer. Then we have proto and text proto, which I'm a little bit surprised by. Tools. Tool has what? FYI, test data, and some static stuff. Static claim main. I don't know what that's for. And then what do we have here? The verifier, which has some assertions and just assertions and test data. And assertions for the AST. Let's look at these real quick. We have the assertion AST, and we're also importing some sort of parser, which I don't know what this is. That's maybe Yak or some descendant of Yak. Is Yak I forget which one is which. And so we have some verifier class. Parses logic programs. Assertion parser collects together all goals and data that are part of a verification program. This program is then combined with a database of facts, which are merely terms represented in a different, perhaps indexed format by the verifier. Okay. So we have this assertion parser, parse inline rule file. These are just parsing functions. They're, I'm going to guess it's what we use the parser for. What else do we have? We have a goal group, some vector of whatever a goal group is. We have a verifier, which is different from the parser. So this is just the assertion parser. Let's see if we can find something with more behavior. Unresolved location. A kind anchor offset begin. So the so Kythe has this notion of anchors, which are basically either files or locations in files. And I'm guessing that's what these offsets are. There's evar. I don't know what evar is. Validate top location spec. Yeah. So where's this verifier coming in? Are we importing it? Is it in the CC file? Here's the assertion AST. Let's look at assertions.cc. Do we have verifier here? I'm not sure. We have verifier underscore that comes from somewhere. Did I just miss where there was like behavior defined here? It looked like an empty class. And where's verifier underscore set to? Well, I'll see if I can find it later, I guess, or rather in another file. Is this it? Verifier/verifier. All right, this looks promising. So verifier is a thing that takes a Boolean, whether you should trace the lex, dump lexing debug information, and whether you should dump the parsing information. And you can load in files, load in rule files, ignore duplicate facts, which is a function. I don't know if it like just actually does the deduplication or sets some Boolean. Dump as dot for graph viz, dump as JSON. Verify all goals. Attempts to satisfy all goals from all loaded rule files and facts. That looks like a function I want to see. So hopefully there's like a verifier.cc. verify all goals. So you pass it in what? A function, which is a bool function that takes a pointer to a verifier, a reference to an inspection, and a string view, which we can think of as just a string. And if we are using fast solver, we're going to run souffle, whatever souffle is, and we'll do some stuff. Otherwise, I guess we are down here. If we're not being asked to prepare the database, we just return false. Otherwise, we set wi, which seems to have the same the same type as the function we saw up here, minus the string view. Where'd it go here? And we're calling solver of this. So it looks like they might use like an actual like sat solver or something. Is that possible? Where is solver coming from? I would hope they did not write their own if that's what they're doing. But they have the souffle interpreter. Where's solver defined here? I can maybe do this. Whoa now. Whoa, whoa. Whoa. How do we do this? Projectile. Is there a projectile grep? Okay, so here's the souffle thing. Go here, and then let's find solver. It should be the class I'm looking at. The solver acts in a closed world. Any universal quantification can be exhaustively tested using database facts. Okay. So they have facts, which I think are technically quadruples. I mentioned this last week that the way that graph, or rather logic databases often work, is they just have triples. Like I think that's the way a lot of ontologies work. You just have a triple, like Jesus is son of Joseph or whatever, and maybe Joseph is father of Jesus or whatever. I don't know why that's the example that came in my head, but that's you record facts like that, and then you're able to use all of the facts to do a sort of graph traversal that lets you ask questions. So I'm wondering if that's what they're doing here. This solver is based on a semi-functional implementation of a higher order logic programming language by Connell Elliott and Frank Fanning. It is not our intention to build a particularly performant or complete inference engine. If the solver starts to get too hairy, we might want to look at deferring to a pre-existing system. That's kind of funny. I'm curious. We don't have access to the internal code. I'm curious how long this has been here. Like if this is part of the original Grok system, or if this was, or maybe if internally they used a real solver, and when they open sourced it, they like kind of wrote their own, or what? I don't know. But here's how it's. Whoa. This is. We've got this thunk ret thing. It's going to return some sort of thunk. And we've got this unify tuple. It's going to take in some tuples. I don't know what thunk ret cut is, or the f thunk is. And we're going to call it unify. So there's some sort of unification. Here is unify. It's going to take some AST nodes, S and T, and whatever, something for this, presumably some information about what to cut or how to think about cutting. And I don't know really what F is doing, but it's some thunk, which I think is in general like just like an unevaluated function, and whatever evar is. We're going to call unify evar es with the cut. So this is what? If E, I guess this is just checking if S can be converted to an EVAR, or similarly with T. Okay, so if S as EVAR succeeds, we're gonna call unify EVAR with the EVAR'd S and T in the second argument, and similarly here. I was confused about E being here, but E switches between S and T. And so the first argument is the EVAR, and S, I guess, can be pretty general in whatever unify EVAR is doing, and so on. Okay, I have no idea what any of this is doing, some sort of solver, but I will look up this paper. I don't even, usually the reason you wouldn't necessarily want it to do this is you want to make sure that you're not having to maintain some logic inference engine with edge cases that might mess you up. I assume they have some plan for that. And I'm going to read this offline. This is only 34 pages. I could ask the AIs about this solver. I think I'm not going to right now. But it does seem like they implemented a solver of some sort. And the truth is, I'm not even really sure what they're solving for. Oh yeah, they have goals, and they want to check that the goals are can be solved or whatever. So let's see what souffle is. So souffle result, run souffle. We have some symbol table, a database with anchor maps and stuff, and inspections. Souffle result, souffle error state, and so on. Okay. See if we can find documentation for Kythe souffle and Kythe solver. I think I was Googling around yesterday, and what? Hang on. Let me do one thing at a time here. Souffle doesn't seem to be well documented. Okay. Then I will pass this to the AIs. How do I do this? I was looking, I saw some comment from several years ago, yesterday, on Hacker News when I was trying to look up some of the differences between Kythe and how they were doing things and SourceGraph, because I noticed that the person who had originally created the Grok project internally to Google is a well-known ex-Googler named Steve Yegge, who is now one of the high-up guys at SourceGraph. So SourceGraph is, in my gloss on it, it's basically trying to reinvent in the public world some of the internal Google tooling. And then there have been other attempts. I think that one of the authors of Kythe was or is at a place called SourceD or Sourced. I don't know if they're still around. But one of the comments I saw yesterday said that, at least as of several years ago, whereas Kythe tries to build an LSP server that works across languages, SourceGraph just proxies to an underlying has like multiple LSP servers and just proxies to the appropriate underlying one. So in that setup, you wouldn't necessarily be able to go from like Rust code to C++ code or to Python code, whereas in Kythe you would. Although Kythe is in some ways a more difficult lift in terms of it's pretty googly. It's got things like implementing your own solvers, which I don't know if that shows up in SourceGraph. Okay, so it's a solver, logic-based verification for state analysis. It's got some abstract syntax. Trees the unification is a fundamental operation in logic programming. It tries to make two ASTs syntactically identical by finding substitutions for variables. Okay, so this is doing substitutions and trying to make the two things the same so that you can check. So I guess the Y is that so you can operate on them. But that's a standard sort of logic thing. Occurs check prevents infinite recursion by ensuring a variable isn't unified with a term that contains the same variable. For example, unifying x with f of x, and then it's got some backtracking if it leads to a dead end. And so the goals of the propositions the solver is trying to prove, and it's got some database, a collection of facts, and some anchors that associates byte ranges, presumably from source code, with AST nodes. Right, so that's basically we have the function foo, and it's in some particular location in the code, so that has some anchor. And the continuations in chunks, the thunk, thunkret, and lambdas, it uses a continuation passing style extensively. Thunk is likely a standard function of thunkret. Functions like unified and solve goal take a thunk f as an argument, and this f represents what to do next if the current operation succeeds. Okay. Sounds good. And cut is a logic programming concept used to control backtracking. If a goal succeeds and hits a cut, certain previous choices might be committed, pruning the search space. Okay, and then inspections is a callback mechanism that allows custom checks to be performed at certain points during the solving process, typically after a goal group has been processed. All right, that's actually really useful. Thanks, Gemini. All right, so what have we learned so far? I really have no idea. Here's indexer. Let's look at indexer. We've got the CXX, the proto, and the text proto. I'm going to guess text proto is mainly about parsing, although not. It has its own analyzer. Record.io is some Google file format. I didn't actually realize it was public. Record.io is a file format used for storing data efficiently, especially in deep learning and other data processing tasks. It's a binary format that packages data into individual chunks called records. It's often used with protocol buffers, known for its compactness and speed in reading and writing large datasets. Okay. Sounds good. All right, so we've got these text protos and some plugins and an analyzer. Should we look at the analyzer for the text proto? You've got analyze compilation unit, which is going to return an absol status. And also analyze compilation unit, but I'm assuming with different arguments. Analyzes the text proto described by unit and emits graph facts to recorder. The basic indexing flow is as follows. Build a descriptor pool from all protos in the compilation unit. Find the descriptor for the text proto's main message by name. Construct an empty message instance from the descriptor. Parse the text proto into our empty message, and so on. Okay. So this all looks pretty complicated for C++ and protos. It doesn't seem like the sort of thing that would be easy to add an integration for. We have this Kythe indexer main, a marked source. I don't know what marked means. Maybe it's like marked up. Maybe it's like a source file with a point identified. a file descriptor walker that's presumably going to walk some sort of like tree or structure of file descriptors, a proto-analyzer, a proto-graph builder. I guess I'll look at the CC file and a source tree, and a vname util. So vname is the vector name. They name parts of the code according to some vector of facts or attributes. And here's the main file. It's an entry point. We've got lots of absel flags. Looks very googly. We've got support for the kzip files, which is their like kind of custom file format for storing index information, I think, or maybe just any information. For Kythe, we've got this read protofile. And then main, the command line frontend for the Kythe proto indexer. Okay, so this is just for the protos. Invokes the Kythe proto indexer on compilation units. By default, writes binary Kythe artifacts to standard out as a sequence of entity protos. This destination can be overridden. So this is like pretty simple in the sense that it's just writing to standard out. It's just writing to some file. It's not like part of some database. I guess you maybe run it manually or it runs in some like kind of batch job. I guess we don't really need to look at the main thing. I thought for a second it was like the main the main file to all of the indexers. I forgot it was in this proto directory. I don't know what a marked source is. Name is the proto-style dotted qualified name. Root is the node to turn into a box context. Now that I'm thinking about it, one of the things that's a little bit challenging about protos is that it generates code. So a thing that a lot of language indexers are not good at, and what Kythe, I think, does is when you have code generation, it wants to index the generated code, which may not be... I forget whether it's typically committed. I think it's not. But you want to be able to generate the code and follow references across the generated code. And so, among other things, the path itself on the file system may be generated. And so all of that kind of has to work properly. So you have to be able to follow from like a proto definition to the Rust implementation and the Java implementation. And so I think that's one of the reasons that proto is looking a little bit more complicated than just processing text files. File descriptor walker, a human readable mediator between the 3/4 element span vectors and the proto compiler's source locations, which contain extra info we don't always want to pass around. Okay, I'm just going to kind of plow through these because I'd like to go around 9:30 my time, which is about in 6 minutes. I'm not going to make that, but I want to see sort of what more information I can glean in a shorter amount of time. So this is just some utility for vnames that seems to be specific for protos. And proto, as I mentioned, is a hard case, so that may not be where I want to be. Back in indexer/cxx, no proto. We've got some hooks for the AST, indexer front-end action, Kythe claim client, indexer main, etc. Whatever VFS is. Some stuff about Clang, like a Clang range finder. Clang utils, index parent map, indexer work list, semantic hash. Semantic hash. I don't know what a semantic hash is. It specifies that hasher should do if it encounters a case it doesn't understand. So semantic hash constructs a new semantic hash using decal string to calculate a string from the template declaration on unimplemented for behavior when encountering an unhandled AST node. I'm guessing that it's just semantic in the sense that it includes semantic information. I don't think the hash itself is semantic. Well, maybe it is. Hash coding via semantics guided something, something, something. Hash coding is an important technology that enables efficient image retrieval on large-scale data. We propose semantic hash, a simple and effective deep neural network model to leverage semantic word embeddings. For example, BERT in hash code learning. don't know if this is the same thing. This is what, from 2018? And semantic hash is from, this paper is from when? Is there a year? How about a year? 2021. Okay, so whatever this Kythe semantic hash is, it predates the AI thing. I'm going to guess it's just some hash that is hashing over semantically useful information, probably standardizing. Builds a semantic hash, blah, 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 such that if R and R prime are similar records, the two hashes are equal. This notion of similarity is meant to join together definitions copied and pasted across different translation units. As it is, at best, an approximation, it should be paired with the spelled out name of the object being declared to form an identifying token. Okay. So this is maybe useful, maybe for faster processing, but it's not perfect. So it sounds like maybe what it's saying is that you, it's maybe a little bit like having a probabilistic data structure, and then if it's probably equal, then you look at the strings themselves or something like that, the actual definitions. Type map, I don't know what this is. A simple, hashable, using type key hash, EQ comparable class for constructing unique keys from types. So this is, you're looking at type information. I assume only in C++, although I don't really know whether this is used on everything that has a type. Clang AST type. Clang is necessarily C, or C in C++ or whatever its scope is, but not Ruby, for example. Okay, so this is taking types and getting a key, a unique key. Sounds good. And I don't know what VFS is, virtual file system. A file system that allows access to mapped files. Okay. Well, that's fine. That's good. And then we see some Clang stuff here. I don't know what claiming is, but we have a markdown file. Avoiding redundancy during analysis. It is convenient to be able to define analysis over a C++ codebase as the composition of separate analyses over each translation unit in that codebase. Why? Presumably for parallelism. This may lead to redundant work being performed, especially when, as is commonly the case, there's a large overlap in the set of headers that each translation unit includes. Such extra work may result in a large blowup, blah, 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 blah. And then this is going to be something about claiming. Maybe you claim maybe you claim some part of it to avoid having everyone redo the indexing or whatever we're doing here. Okay, so I'm supposed to go. I feel like I understand much more. I have a better sense of the code base. I still don't feel like I understand entirely the flow of when you, let's say, finding the definition of a C++ identifier. So if in C tags, you have some tag file, and I can jump to the definition, and it will find out where that thing was defined. How it does that, I'm actually not sure. We could look at the tags file. Is that interesting? I don't know if that's interesting. I think here. And let's bring these up side by side. And let's see if I can find the line 351. See if I can find AST node current. Okay. So this is the text file on the right here. We see something about 351, whatever this caret A is doing. I assume that this is some sort of notation that is some non-printing characters that says something along the lines of if you're looking for the definition of current, it's on line 351. And then whatever this is, maybe the row number or some sort of offset 12531. But how does it know that I'm an assertion.ast? That I don't know. But that's somehow it's figured that out, presumably using some compiler-like techniques. And let's just see if we can find out where that is done. So that's probably in the extractor. We have the Bazel artifact reader, CXX details, dump Bazel artifacts, language. Let's pull this into its own frame. Here's a README. An extractor that builds index files from a Bazel-based project. Extractor builds up a kzip file for each CC library and CC binary. In the project, this extractor is based on the Bazel action listener rule. Okay. It allows tools to develop and insert extra actions into the system. Okay, so we're going to insert extra actions as we're mapping over rules. Currently, Bazel doesn't have a convenient way to use action listener outside of a project. Okay, I don't know what that means. Like maybe for dependencies that are not in your project. So first you need to add action listener to the root build file of the project. Oh, okay. So they're saying that you need to add this to your build file because you can't just use the definition from the Kythe source code that you downloaded from Git or whatever, I think is what it's saying. Although who knows if this is still up to date with changes in Bazel. So it's the extractor. The command is opt Kythe extractor Bazel CXX extractor. Passing in the extra action file, sending the output to the I don't know what output is doing here, but I don't know if it's like a command line flag or just a root. But at any rate, it's going to be output something, and then it's going to be named by the action ID in the kzip format, and we're going to record the fact that it's CXX. And then the location is going to be some JSON file with vnames. Why JSON and not proto? I don't know. That seems morally wrong for a Google project. And then the data is going to be vnames.json. I don't know where that comes from. And then the out templates, whatever out templates are, I don't know, are going to be the cxx.kzip. I'm guessing this means this is the output and their templates because they like depend maybe on the variable. And the action the action listener is extract CXX, and the extra action is extractor, referring to this. And the mnemonics are CPP compile, and it's publicly visible. Let's look up Bazel mnemonics again. Bazel glossary. I'll add this to Wallabag as well. A mnemonic is a short, human-readable string selected by a rule author to quickly understand what an action in the rule is doing. So some examples are Java C, CPP compile, and Android manifest merger. So it's just some human-readable string that describes what it's doing. As I guess mnemonic as opposed to like a formal name that's like the path to some function or whatever. The extractor provides a vnames.json file that tells the extractor how to translate certain file paths. It requires a vnames.json. For example, in Bazel project, Java files. Okay, so I think we saw this before. So you may need to like strip a prefix or whatever. And so here's an example of a vnames.json. Let's look at that. So I guess this is saying if your pattern matches this, then the corpus is whatever corpus is. That doesn't seem to be a variable. Maybe that's like something you fill out. And they're just using all caps corpus as a placeholder. And the root is Bazel out/bin, I guess, which we know from here. And the path is @1 @ Who knows what that means? But I guess that's the first, or I think that's like regular expression stuff for some group. Presumably the thing that comes after virtual imports. Or something. Regex groups. Maybe I'm not getting it right. I don't know. I assume that's more or less what it's doing. Although it seems to increment 1, 2, 3, 2. Is this what does @1 mean here? I probably did need to ask this of 2.5 Pro. It's a placeholder that refers to the content captured by the first capturing group. So not the 0th. Let's break it down. Pattern. This is a regular expression. The crucial part is the dot star. Where's the dot star? It's at the end? Okay. Okay. Will match and capture any sequence of characters that follows this thing. Yeah, okay. So it signifies the value of this path. The path field is intended to be constructed dynamically, and so on and so forth. All right, so I had forgotten that bit of syntax. I don't know which regular expression syntax definition that's part of, but there's like only 2 or 3 of them that are in a lot of use. Okay, and then to run the extractor on all targets, it's a test. Why test? You're calling Bazel test experimental action listener extract CXX, and so on. And you can find the kzipped files by calling the find utility. And then you can export extractor from sources. Exporting Kythe project CD into the Kythe project, and then you're calling Bazel build. Wait, what? So the Kythe project is set to the Kythe repo. We're going to go into the Kythe repo, and we're going to build the extractor. Oh, building it. I don't know why. I read this export. Yeah, building from source. Okay, great. Okay. This is building the extractor. All right. So let's look at this thing, this extractor. So where did it go? Opt something or other. Opt Kythe extractor is Bazel CXX extractor is the name of the thing. We can look in the build file to find out where that's defined. Presumably it goes in the main file. So that's a lib. The binary is CXX extractor main. That makes sense. I don't remember if we looked at that one already. For CXX in general, we briefly glanced at the proto one. So here's the CC file, the implementation file. And you're just getting a config and calling config extract. Supported language KCPP. Okay. Well, that's not very enlightening. So do we have a config? I don't know. Let's just look at a couple of these other ones, like CXX extractor without the main. This looks promising. We're importing just about everything under the sun. It's a lot of lines. This is just checking whether they're standard in. We have this thing over here, running hash. extractor state, file state, pop file, add file. These are some, I guess, callbacks for dealing with records. Claim pragma handler, file changed, etc. Macro expands. Extractor action. An extractor action is a Clang preprocessor front end action. So this is some Clang thing, and I think this is about where I'm ready to stop. So we've at least seen that, like, eventually they're going to call some Clang preprocessor thing, and at least we know where that is, which is better off than we were last week. So this is extractor action as a class. This is execute action as a function. We're going to get the compiler instance and the front end options and some inputs, I guess. And the main source file by normalizing a path. And we're going to get the preprocessor, and we're going to add preprocessor callbacks. Making a unique pointer to extractor PP callbacks. And the thing that we're like constructing some extractor state thing, it looks like, with an index writer, something, whatever a source manager is, something presumably for managing the source files. The preprocessor, the main source file transcript. We saw something about transcripts last week. It had something to do with like kind of tracing the output of the C++ preprocessor. Also passing in the source files, etc., etc. And on the index writer, we're going to cancel previously opened files. Then we're going to, on the preprocessor, enter the main source file, create a Clang token, and we're going to lex tokens while the token is not end of file. And that's it. So the work is done from by the preprocessor and setting the PP callbacks to these callbacks. Extractor state. Let's see if we can find extractor state. Doesn't sound like a state doesn't sound like a thing that does work, but what do I know? Didn't I copy this? Extractor CXX. Okay. What was it? Extractor state. Okay, so we have a struct. We have some compilation writer, a source manager, preprocessor, string, under blah blah blah. So is maybe the thing that we're doing is just like writing down. We're just recording what the preprocessor is already doing. Is that it? I feel like that's not it. What variables do we have? Extractor action. And we have a callback here. And so, so are these callbacks being used anywhere? The extractor PP callbacks are hooks. It hooks the Clang preprocessor to detect required include files. Where was I? Execute action. Here's end source file action. Include information about the header state in the CU. So this seems to be doing work. It's also got a callback. I'm a little bit unsure why. Seems like the only thing we're passing in here is this state. Is that enough? Maybe it's enough. So it's got the index writer, which is presumably something that just writes. The source is the preprocessor, which I think is just the preprocessor. The main source file, the transcript, source files, and it just all looks very stateful. So what is it? What's actually doing the work? Let's try just grabbing this whole thing. Can I do that? I don't know where this ends. All right, let's ask Gemini. So here, what does execute action actually do? It looks like it sets up, it grabs the C++ preprocessor and passes it some state, but it should actually be running some callbacks. Let's see what Gemini has to say. Happens indirectly as a consequence of driving the preprocessor, while a more explicit higher-level callback is invoked later in end source file action. Is it? But is this actually called? Oh, no, enter main source file. But when is end source file action called? I don't know. But this, like we observed before, does seem to do some work, like recording some stuff. Preprocessor retrieval, registering callbacks. This is a critical step for the callback method. It's a class that inherits from Clang PP callbacks. It's an interface that allows you to hook in various things by creating an instance of blah, blah, blah. You're telling Clang whenever one of those predefined processor events occurs, call the corresponding method. And the extractor's state is passed to extractor PP callbacks. The state likely includes references to index writer. Yeah. And it will use that to record information as the preprocessor runs. For example, an inclusion directive callback, an extractor PP callbacks might record the included file's path and content into source files. This interacts with your compilation writer. Enter main source file tells the Clang preprocessor to begin looking at the main source. Yeah, thank you. And then the lexing is where it does work. Yes, I understood that. It encounters directives like include, define, etc. This is when the methods of extractor PP callbacks are invoked. For example, if you encounter include foo, the inclusion directive method, if overridden, will run. But did we register anything like that? So we're passing an extractor state, a writer. I don't know, man. So the state is the state shared among the extractor's various moving parts. None of the fields in the struct are owned by the struct. So this is just some shared state that's like passed around. But it doesn't seem like we're actually passing in any callbacks. So here, here. Oh, maybe. Maybe there is some behavior. Claim program handler wrapper. We've got some wrapper thing. Add file. Record macro expansion, record macro expand. Okay, this has some behavior. That looks satisfying. So what was I getting wrong before? Extractor PP callbacks. No. Oh, I see. I think what I was getting wrong before is it's that we are parameterizing this PP callbacks thing by the state, and the PP callbacks is the thing that has all the behavior. So for example, they all depend on the location, the macro name, the macro definition, etc. And that should all be part of the, but it should at least all be derivable from the extractor state, I guess. Or at least the combination of the extractor state and the whatever the, as the preprocessor is finding stuff and expanding macros and whatnot. Okay, so I'm not sure why that took me so long to figure out, but that's that. Okay, so I have a pretty good understanding of it. It's pretty complicated. I think that the idea of kind of like adding support for a new language seems pretty daunting. It seems like the C++ support is pretty low level. You have to have some knowledge of Clang and kind of know what to do. Is there Python support? I don't know. C++, Java, and soon Go. Okay. So I think that's kind of one of the things that's holding this approach back, is that that you need to tap into a compiler, and so it's not going to generally work across compilers. So, for example, this seems to be pretty tied to Clang. It presumably will not work with GCC, and the tooling to support other languages may not be as nice as Clang. And so that is one thing. But even if you had support for a language, you would have, it would kind of be dependent on the build system and dependent on one particular compiler or tool set for that language. And so it wouldn't generalize as much. And I think that maybe what SourceGraph is trying to do is they're trying to make something that's, the features are like a little less cool, but it's easier to generalize because you're just kind of hacking on top of some existing stuff on a per language basis rather than trying to make the same structure work across languages. So I'll think about this some more. I don't know if this is, if jumping into this is something that's worth doing. It does seem like it would be nice to have an understanding of the code base that's as rich as what Kythe provides for feeding to an LLM, because then the LLM could do things like figure out on its own what information it needed to understand some task. Whereas right now that's pretty hard, at least for larger code bases or for multi-language code bases. But I'm guessing that one of the reasons that we don't have a nicer way to do that is that it's just hard at this point. So we'll see. Anyway, that's a second look at Kythe. Thanks for watching. This is Ants Are Everywhere.